11th. I think in this case A and C again. Yeah, tell me, shall we do it or you have understood, or what the working you have done it is meeting up the kind of answers? We can discuss. Okay. So which of the following statements are true? So f is a differentiable function already known. So when a function is differentiable, left hand derivative should be equal to right hand derivative, right? At x equal to c. So they are just telling me at c. So my LHD is f of c plus x, or I'll use that one, f of c plus h minus c minus h first, minus f of c over minus h, limit h approaches to 0, is my L of f dash c, right? Right of f dash c is f of c plus h minus fc over h, limit h approaches to 0. And they should be equal because this is given differentiable. So what is being told to me over here is, first option, this exists and equals to f dash c. What I'll do, f of c plus h is there. I'll do minus fc from my end. I'll do plus fc and minus fc. You understand? So this forms R of f dash c. And if I take minus common and take it down, this becomes my L of f dash c, isn't it? As L or R f dash c are equal to f dash c only, because it is differentiable, so I make it 2 times f dash c, 1 by 2 out will go, it is f dash c. So it is equal to f dash c. That's why the answer is A. Why not B? Why not B? We will understand that also. Given a function f and a point c in the domain of f, if the limit this exists, existence of limit doesn't mean that it is differentiable. Existence of limit will give you what? You do the same stage, you know, you will do the same steps, you'll reach out to the same place, but you cannot add them up because you don't know that they are equal or not. You understand? Existence of limit makes not clarity that existence means they can be added and becomes the derivative of a function. So the limit existence is different from the derivative of a function f dash x. That's why this answer will not be differentiable for that function. Now going for this, you have to do direct derivative for greater equal to 0 means greater than or less than it is being existing in this. If I take this, so in this case you just have to direct differentiate the given function and apply the limit x approaches to 0, LHD and RHD. You understand direct differentiation? Apply product rule and see whether the answer is coming in within zone or not. In this case, g dash x exists and is continuous. So when your g dash x will come, your g dash x, whatever the new function being found as g dash x, its LHL and RHL will not be equal. There you will be getting a stuck up. That's why this answer will be wrong, and you will get only the existence of g dash x. Is it okay? To move on to the next. In this case, I guess option is again A and C. and there is some mistake which I feel that it should be this brackets. These should be these brackets. There in the exam also. When you have max min type of expression, it works like this. So, tell me. So B and D we will just do and get it done, na? Without that we cannot do. About G, if you want G, so whatever return, we'll go with the kind of movement with respect to this. I believe so. The answer is A and C. If it is not matching, let us see. If we see B, G is discontinuous for all integers. Is saying like that. So we take up, if it is continuous at x equal to some integer, मान लो k. Let us suppose x equal to k is integer. I'll calculate LHL, I'll calculate RHL, I'll calculate VF. And I'll make derivatively equal to each other. Because I want it to be continuous. On the contrary, I'm going. Okay. So I'll see P of k first. My answer is k square plus 0. Clear? So this is my value of function. I'll go with limit x approaches to k minus LHL for g of x. This is my LHL. So limit h approaches to 0, k minus h square fractional part of k minus h square. Am I clear? This forms k minus 1 square without limit. Any integer, some value is there which I subtract something. Let us suppose if 3 is there, I subtracted 0.00, so something is there. What you will get? 0.9 something? 0.9 something means if you just want to write the answer from this, what will be the value? I would say that you should take it out under the mod, because it is under the root, na? And it will without mod also, because fractional part always lies between 0 to 1. It goes. And k minus h will give me the value which is 1 minus, right? One minus h I should give, or 1 or k minus 1 I guess. Let us take the example, then we will write the answer. If you have something 2 minus h is there, I am doing fractional part. Example, 2 minus h fractional part is not h, 1 minus h. Don't you think so? This will be like this, na? This is 0. This is nothing but 1 minus h. Right? So 2 becomes 1. So it becomes k minus 1 minus h. And h approaches to 0. It will go. So I'll get k minus 1 square plus k minus 1. Is it clear? So on expanding the things, you got the value as k square minus 2k plus 1 plus k minus 1. k square k square minus k is the value obtained from this place as LHL. We'll go with RHL now. When you apply k plus h, what will happen to k plus h now? Tell me. If you go for k plus h, you have square plus k plus h fractional part. Mod, there is no need. We'll get only h, and h is 0, it is gone, and will become k only, k square. LHL should be equal to RHL. So when LHL is equal to RHL, your k is becoming 0. Means at 0 you are getting continuity. You understand? That's why this answer gone. And if it is written also, this will also go. Maybe differentiable also. You can check for that as well. So we go next. This question, there is some mistake. It is something like this. This question just change over like this. This is the fx which is written is not right. This is right. This is the actual function. Whose involvement is there in finding the value of this? You want me to do this? Or is it clear? The answer supposed to be, I think, 91. No, 7. Answer is 7. What do you want? Shall I do it? Or you have understood? Okay. This is given alpha e raised to the power 2 pi I over 13. Means alpha is 13th root of unity. You understand? You're raising the power 13 on both the sides. You get alpha 13 equals 1. Or I can say that alpha 0 plus alpha 1 plus alpha 2 up to alpha 12 is equal to 0. Sum of the 13 roots of unity is 0. Did you understand? Now using this concept, we need to just apply fx this, which is this actually, to this place. We need to know this value. I'll write it 1 over 13 bracket sigma open f alpha power 0 x alpha power 1 x alpha power 2 x and alpha power 12 x. Right? Is that clear? Now, what is fx? Fx, I'll place it this only because this value is this only. So 1 over 13, 7 plus sigma k1 to 50 ak x power k only. Because alpha x to be replaced here, my alpha 0 means fx only, so I'll keep it this only. Moving to the second, alpha x to be placed at every place. Wherever x is sitting, I have to replace x by alpha x. My expression will change over to 7 plus, this is for the first, 7 plus sigma k1 to 50 ak alpha x power k. will go like this. Third one will go 7 plus sigma k1 to 50 ak alpha square x full power k. Successively running, the last one will be written as 7 plus sigma k1 to 50 ak alpha 12x raised to the power k. Am I right? Is it okay? Shall we proceed? Now what do you observe? 777 will come how many times? So 13 times 7 will come here, 1 over 13 here, plus. From this place, I have to pick these values together and write it in one like terms. I'll get sigma ak k1 to 50 x bar k plus sigma k1 to 50 ak x bar k alpha bar k. Right? Then you have sigma k1 to 50 ak x bar k alpha 2k. Successively, the last one goes sigma k1 to 50 ak x bar k alpha bar 12k. So from this place to this place, I will take up sigma ak alpha bar sigma k1 to 50 ak x bar k in the bracket alpha bar k alpha bar 0 plus alpha bar k plus alpha bar 2k alpha bar 12k. You understand? This will come all together. So this is nothing but what we know. So when the consecutive terms will go, this will give you the answer 0. This will vanish. And you are left over with this and this. Answer will come out to be 7. Am I clear? Now, 14th question. I think the answer was 1. Yes. You want me to do or you have understood? I think its answer was 4. Answer was 4. Is it okay or to be done? Okay. I'm doing that. Understand, x square written sin ft over x minus 1 square is there. Take the integral x approaches to 1 up and integral to be applied to this dt function. So I've taken the lower one out because it is a constant. So now what I'll do, on applying limits, denominator becomes 0, numerator becomes limit same, again the answer is 0. So 0 over 0 form applies LH rule. LH rule, differentiation of up and differentiation of down. Denominator becomes 2 times x minus 1 derivative. Numerator goes with Leibniz rule. Leibniz rule says x square as it is sine of f of x square comes here into 2x minus lower limit, there is no point because derivative is going to be 0. This is the observation, limit x approaches to 1 still running on. On that, this your 2 goes off. Still if you apply the limit x approaches to 1, denominator becomes 0 and numerator becomes 1 sine f of 1. F of 1 is 0, so sine 0. So 0 over 0 form again applied. So LH rule is again activated. So we'll apply the LH rule, you know L'Hopital's rule. Denominator becomes 1, numerator becomes product rule. X square derivative is 2x, sine of fx square kept as it is, plus, this was x cube. So we'll go with this, 3x square, derivative of x cube. Okay, 3x square sine fx square as it is, plus x cube as it is. Sine becomes cos of f of x square multiplied by chain rule f dash x square multiplied by 2x. Right? You go for applying limit x approaches to 1 in this now. When you go with 1, this will become 0 because sine of f1 is there and f1 is 0. So no need to see this, only for focusing on this. This becomes 1 cos of f0 is f0 is 0, so cos 0 is 1. Then you have f dash 0, f dash 1, sorry, not 0, f dash 1, which is 2, and 2 times 1. The answer becomes 4. Is that clear? So this is over